The world is changing fast. New technologies are impacting how we think about products, services, and the way we live our lives. Nowhere is this trend more present than in financial services, where new business models and customer expectations are changing our conceptions about banking, finance, and the very nature of money. Welcome to Rebank, a visionary podcast about banking, fintech, and the future. The future of banking is here. Hello and welcome to Rebank. I'm your host, Will Beeson. Today we're thrilled to be joined by Paul Taylor. Paul is the founder and CEO of Thought Machine, a brand new banking platform combining a Google-like approach to software with bank-like requirements for functionality. Prior to Thought Machine, Paul headed the text-to-speech group at Google. He joined Google in 2010 when they acquired his company, Phonetic Arts. Phonetic Arts developed speech synthesis technology and was based in Cambridge, England. Paul has a PhD in speech technology research from Edinburgh University and started his career as an academic. Since then, he's founded 3 companies and taught at Cambridge, in addition to his work at Google. Paul has published over 80 papers on speech technology, including the now standard textbook in the field. As always, connect with us on Twitter, Facebook, LinkedIn, or on our website at bankingthefuture.com. If you like today's show, please subscribe on iTunes or your podcast platform of choice and leave us a review. Thank you very much for joining us today. Please welcome Paul Taylor. Paul, welcome to Rebank.
Welcome. Thank you.
Yeah, thanks for joining us today. So tell us about Thought Machine.
Okay, so Thought Machine is a fintech company headquartered in Shoreditch in London. We were formed 3 years ago, and our mission is to radically transform the banks, the technology that underlies banking.
So that extends across core banking and other components of the bank technology stack?
Yes, it does. So can I say how we got into this?
Please.
And when we started off, we were working with a project with a major bank, and we were focused very much on the AI machine learning area. And that bank had a real interest in this area, the way that many banks do. But the fundamental problem was it was very difficult for us to get our technology implemented. When we went to them and naively asked, can we use your APIs? Can we get data feeds and things like this? We realized that the core banking technology, as in the technology that really is the underlying foundation of the bank, was written in a completely different era with a completely different set of design requirements, and just really wasn't set up to do with rapid change, to be able to do data feeds, to be able to do all the things that we do in the modern world with regards to how we actually build modern technology. So it was partly out of necessity that we realized that our business plan wasn't going to execute particularly well if we couldn't get any data. Machine learning systems need data. So we had to look at the core banking technology, decided that it was ripe for innovation and change, and went after it. And 2 years later, here we are. So we pivoted, decided to radically fix the underlying technology in the banks so that modern services such as machine learning could be facilitated.
Interesting. Okay, so that kind of provides a bit of insight, answers the question as to how you specifically got into core banking technology, because your background, as I understand it, is PhD level kind of speech to text AI machine learning, right?
Yes. So it is an interesting journey. So to give you a bit of background, so I was an academic researcher in speech technology, machine learning, AI, long before it was fashionable, and I loved it. So I did my text-to-speech was my particular speciality, but I mean, it was all part of the same mix of subjects, speech recognition, speech understanding, machine translation, those sorts of things. And I was a university academic. I worked first in Edinburgh University and then later in Cambridge University. And all through the 90s, we were building this technology in universities. It was a small field, and let's say it was basically a very uncommercial field. And I would say it was even an unfashionable field. It wasn't really well regarded even within the university sphere. AI was seen to be a bit of a kind of science fiction thing that didn't really work. It was very expensive and it didn't have much appeal. But I always found it fascinating. And then I got into the startup world in 2000 and formed my first company, Rhetorical Systems, and we productionized that technology. I sold that to Nuance Communications in 2004, took up a post at Cambridge for 2 years, wrote a book on text-to-speech, which is still there. I think it's number 300,000 on the Amazon bestsellers list, so it was hardly an alternative career path, but I wrote a book then for my second company, Phonetic Arts, in Cambridge in 2006, and that was acquired by Google in 2010. And then we entered the world of I entered the world of Google, which was quite amazing. And that text-to-speech system became the Google text-to-speech system. So it's on every Android phone shipped since 2012. So it's installed on over 1 billion Android phones, and it is the voice that does all the Google search and driving directions. So driving directions, accessibility, voice search, all those sorts of things, used for many, many purposes, speech translation as well. And so I did that for several years, and then left Google 2013 to find Thought Machine.
Wow. Okay, so Google recently has made some tremendous advances in text-to-speech, speech-to-text, speech-to-speech when it comes to kind of simultaneous translation. I think they just announced some new headphones which can kind of listen in one language and kind of translate it in real time into your ear in another. As a relative outsider as opposed to that space, but someone who through the podcast has started using platforms like YouTube more and more. I mean, it's amazing to see the automatic subtitles, for instance, that they create, seemingly instantaneously, and the accuracy levels are incredibly high. So that was presumably the stuff you were working on with them.
Yes, and let me say that. I mean, it might seem amazing from the outside. It was amazing being there at the same time. I mean, we have been talking about these sort of applications for decades, and we have been saying that wouldn't it be good if you could do speech-to-speech translation and even then, but it is a long journey for us. I mean, it was 20 years working on that before it got ready. But when it happened very quickly, and it's a confluence of many factors. First of all, the individual systems got much better on their own in terms of accuracy. Our ability to get data, because all these systems are trained in data, our ability to get data really made a huge leap forward. But for example, and just the raw level of resource that we in Google that you can kind of throw at these things meant that one team of a few dozen people doing text to speech, and another team of a few dozen people doing speech recognition, and another team doing miniaturization and speech translation, and that is hundreds and hundreds of people. But when you put it all together and give it a lot of polish, then you can have it come up with these amazing inventions, such as a speech translation system that works in your ear. When I was a kid, I was amazed by Douglas Adams and the Babel fish, and it's there. I mean, it'll be a little time before it's got the real time sophistication, high accuracy, but it is getting there, and it's getting close. It's quite incredible. I mean, people have said it before that we read science fiction and that we're inventing these things a lot quicker than we expected. So we don't have starships, we don't have faster light travel, and we don't have teleport systems, but we've got all the rest of the stuff, and it is very impressive. I mean, we'll know with those devices when we really win with that, when we see tourists and people who aren't techies going and using speech translation reliably on holiday and not freaking out about phrase books or making strange kind of miming gestures in restaurants when they want to order.
Mm-hmm. Well, I think one of the reasons I was most interested in connecting with you, apart from getting into some of the detail of Thought Machine and the innovation that you guys are pursuing there, but was really, given your background, kind of thinking about some of these technology-based, technology-driven trends that we're starting to see, and I think the speech-to-text AI is a great example. Stuff that has been slowly burning away for the past 20, 30, 40 years that we're starting to see gain real traction. And it sounds like AI is definitely one of those. AI machine learning definitely one of those pieces of technology. virtual reality was, how many times has that been through the hype cycle? And now it feels like it's actually coming together. Quantum computing as well. Does this moment in time seem as powerful to you as it does to me in terms of technological development and transformation?
Yes, it does, and it's. There's many trends that are amazing. The trend that I like to do is just. I worked on the Android team in Google, and just we went through that the smartphone revolution was incredible, and maybe one of the most significant events in all technological development. But it is a democratization of computing power to be able to have really very powerful computers, in people's pockets, and most people having one was amazing. I remember in Google just tracking the kind of demographic spread of smartphones. First of all, they were expensive devices for a few, and then they became ubiquitous in the developing world, and now they're becoming ubiquitous in the developed world. And for example, linking it to banking, we're now moving into an online only and mobile only banking world in developing countries that haven't had the banking infrastructure we've had. So just completely leapfrogging multiple generations of technology, that's a very powerful trend. With regard to the AI, I think that's exciting. It always seems to be a bit of a value add. So people love the experience. It's an experience sort of play rather than something fundamentally changing any industry yet, but that could come.
Okay, so that kind of provides a bit of context for your transition from some of the deep tech AI-based work into banking systems. So when you first kind of came to core banking technology and thinking about what the shortcomings were and how you could do things differently, what was it that kind of motivated your thinking around Thought Machine, that you could do something different?
Yeah, so I've already spoken about the long years doing the AI stuff, and let me just say, it was tremendous fun, but it was a constant uphill struggle in the complexity of what we had to do. So natural language is an extremely complex problem, and still today there are many ways about how we talk or how we understand language or the grammar of language that just baffle us. And by us, I mean experts in the field. So while rewarding in the end, it was a long slog. And when we launched the Google text-to-speech system, it was tremendously successful, and I didn't, I felt that victory had been achieved. That I didn't feel like doing it for another 20 years. And so I thought about doing something quite different. There are various things that contributed that fed into doing Thought Machine. First of all, as an already successful entrepreneur, there was your mindset is different going into it. I'd done the classic kind of British problem of building two reasonably successful companies but selling out to large American companies. So I thought, right, I don't want to do that again. Let's build a company that's got a sustainable, long-term, high-growth future. In Google, though, I noticed that there was a lot of things that were not actually that complicated to do, but just things that Google did very effectively and very well. So, for example, a very simple thing was the speed at which the Google autocomplete. So, it's not a particularly complex bit of code to write, but the fact that it can do it so quickly is what makes it magical, and that is hard. And it was a large amount of scalable technology that enabled that. So, and I also thought it would be good to, looking at examples of Uber and other things like that, you kind of go, it is quite extraordinary that no one was thinking about taxis at all. And if you ask most people, they probably thought the taxi industry was fine. Then Uber comes along and radically changes the industry. Where I'm going with this is that technology, we don't have to have these incredibly deep, sophisticated systems to make a technological impact. What we need to do is, in many cases, is just do the basics well, okay? So, pondering things like Uber, pondering many other experiences, I thought, when I left Google, I wanted to work in fintech because it was, the happening thing in London. But it did make me think that instead of trying for something, incredibly difficult, deep tech sort of play, why not have a look at the banking industry? As I said, we started off doing machine learning, but I really thought, let's have a look at this core banking problem. And what struck me about it was that, first of all, a lot of people in the industry were afraid of banking, core banking. People told me, don't touch that. It's complicated and you'll never get anywhere and you'll regret it. But deep down, banking is simple at its heart. You're making transactions, you're making interest payments, you're calculating fees. The key thing, which is relating back to what the Google thing is, to do it extremely efficiently and extremely well. Current core banks don't do it particularly efficiently, but they do it well in some sense that it basically, it functions and things like this. So the challenge is, you cannot build a kind of flaky core banking engine. It has to be extremely reliable and extremely robust. But that said, I thought, why not try and do some of these basic things very, very well, and if other people want to do cool stuff on top of that, that's fine. But I wanted to have a play at building the foundations of the bank rather than building the kind of the more fancy bits.
Okay, so how are you guys approaching this differently from the way that incumbent software providers or internally developed core banking systems that have been built?
No, that's an interesting question, and I do get asked it a reasonable amount of time. But I find it difficult to answer because I don't have much experience of how these people have built the software. I'll answer it in a different way if I can, which is we come at this as so I'm from Google. Most of the top team are from Google, so we were trained inside the Google machine as to how to write code and how to build systems. And the key to many of these things is how to build massively scalable systems that do not get themselves into a mess. So, I think everybody realizes that banks are incredibly complex systems, but they do not have to be that complicated. That is a historical accident over many decades, and by the fact that many of these systems were not commissioned by software people, so that they were seen as means to an end rather than the actual bank itself. So I think still in many bankers' mindsets, they would see the core banking engine as a facilitator of banking, whereas, for example, I don't. That is the bank, and and people are there to help run that and maintain it. So we have built this system, from scratch using the best practices of modern cloud computing technology. And we've approached it from that way. And it is very different from how traditional vendors do it, but that's not our... We didn't set ourselves up in opposition to them, and it is not a kind of reaction to that. It is just that, this is the agreed best way to develop technology, and it applies to every problem. It doesn't matter if it's hailing taxis or photo sharing or making financial transactions. There's a best practice way to do it. It doesn't mean it's perfect, because we're still evolving a cloud computing world and all the time. But that approach is the best approach we know, and there's many benefits flow from it. So it is unusual in the industry, but we think the industry is moving in our direction. So in a few years' time, it'll probably be less radical than it seems today.
How would you describe the architecture broadly? You're talking about cloud computing. I understand that some new cryptographic advances, things like smart contracts, also play an important role in your system. How would you describe the system?
Well, at the outside level, it is a system it is a cloud computing system, so it runs on all the main cloud computing platforms. We develop mostly on Amazon AWS, but it can run on all of them. And it is, as with most of these systems, it is an API, microservice or service-based architecture, and so a service like the treasury system or a CRM system, each one of those is a service. Each one of those runs on its own server. The bank can scale very quickly, so without much warning, if you add in lots more transactions, lots more users, it automatically scales up by taking in more servers in the cloud. So that's fairly standard, but to do that well, we've got a database which obviously stores all the transactions, and that's a strongly consistent database. And a few other principles. So the bank is completely real time. Banks traditionally have some sort of notion of batch processing, or they copy data from various places from one place to another place. whereas our bank is real time and it has a single source of truth. So if you want to know, for example, just something basic, how much cash is in the bank, or what is my exposure to this, you have all that information in real time. Banks spend a lot of time aggregating data to get regulatory reports together, to get treasury functions together. We do that in real time. So, for example, if somebody just does a normal transaction, spends, goes to a shop, buys a packet of crisps, spends on a card, within 60 seconds that's appeared in the balance sheet. We know the cash reserves of the bank dropped by 80 pence or whatever it is. So we can see that. So at the external level, single source of truth for everything in the bank and real time. Now, that actually makes the architecture easier, but it does mean that you need a single database, and the database is replicated across multiple regions to make sure that there's no fragility there. So we do that. When it comes to the financial part of the bank, we have got a very pure architecture for that. So partly inspired by the world of Ethereum and blockchain and Bitcoin, I've always been interested in smart contracts. And smart contracts are an ideal way to facilitate financial transactions. Now, smart contracts in the financial world have been concentrated mainly in the investment banking world, where, for example, two sophisticated banks would make a trade with one another and they would use a contract for that. In today's world, or the old-fashioned world, what would typically happen is that the traders would make that contract. So one would borrow $1 million from another bank and say, I'm going to repay you in 30 days with this interest rate. And then there would be a back office function that several days and sometimes weeks later would complete the paperwork and actually move the money. But this is kind of nuts, because, this is just woefully inefficient and prone to mistakes and errors. So what a smart contract in the investment banking world would do is it's a single way to describe the technical part of the contract, the legal part of the contract, and actually move the money as well. So it's written in code, and if two banks were trading, they would cryptographically sign this contract, and once it's signed and live, the money would move immediately. If you want to put it a different way, the contract can do stuff, whereas a normal written contract is just a statement of intent. What we decided to do is use smart contracts for the normal banking products. So we do the full range of banking products, everything, credit cards, mortgages, in the UK, ISAs for tax-free savings accounts, checking accounts, current accounts, everything is all done, and we all do it within a single set of smart contracts. So if you as a customer in me at the bank, you take out a car loan, what you're effectively doing is signing a contract with the bank, and you have a way of signing it, the bank has a way of signing it, and then that contract goes live, and that's all that happens. And it does the initial payment from the bank to you for the money, and then month by month it does all the payments back.
When banks traditionally think of their core technology stack, it includes things like a core banking system, which is often simply some sort of ledger, which then provides information to other components like a risk management module, a treasury module, regulatory reporting modules, CRM, et cetera, et cetera. What does Thought Machine do in terms of those ancillary systems, those that connect with the core banking engine, that take information from core banking, but that use it in different ways?
So we started off building a core banking engine, and that was the bit that used smart contracts and cryptographic signatures and ledgers and all those sort of things. And we made good progress, and we demoed it to many banks and got a lot of interest, a lot of traction. We found out, though, that on its own wasn't a sufficiently well-rounded solution. And part of that stems from the architecture. So the challenge or difficulty we found is that linking a modern cloud computing core banking engine to a legacy treasury system, for example, is hard. These things don't coexist well. And so we realized that if we were going to succeed in this commercially, we were going to have to expand our offering, and we were going to have to expand it so that we did more of these functions. So basically, most of the functions you already described, treasury, CRM, things like that, we do. And the idea is that without that, it's going to be an unrewarding experience for the bank. But all these systems fit together quite well. So what is a treasury system? If we just look at the simple aspects of a P&L and a balance sheet, I mean, the balance sheet really is you just add up all the transactions in the bank, and there it is. And the P&L is basically you just add up all the interest rate movements and the fee movements one way or another, and there it is. In and of themselves, these are not hard things to do. The challenge is to be able to do this, effectively and to do it efficiently. So, but we spend a lot of time on that, and we have a data analytics capability, for example, and that data analytics capability can suck in all the data from anywhere in the bank, so all the transactions, but other things like change of address or other things like reg reporting mechanisms, and then that can produce different reports. And the balance sheet is just a report, P&L is just a report, but we have reg reports in there as well. So when we were expanding the treasury function, what ended up being a requirement that we would have to do to finish the bank has actually become, a kind of an additional product offering in its own right, because we've now got real-time data analytics. And that means that data scientists in banks or people doing compliance or reg reporting can write their reports relatively easily, knowing that they can capture all the data in the bank because it's there in real time and it's not difficult to get access to. So, it is more work to build all these bits, of course, but it's been rewarding. And the end result is a very frictionless, well-integrated, complete bank.
Where are you guys in the development of the platform at this point? When do you expect to be live to customers?
So we're in a pre-production state right now. So the Vault OS MVP is finished, and we're now trialing it with multiple banks. And go live will be end of Q1 2018. Wow. So we'll be ready. I mean, it has taken a few years to build. But I mean, all along that journey, we've been doing trials of banks and demos of banks. But 2018, we'll see the first deployments.
Mm-hmm. You made a really interesting comment a few minutes ago, which was around bankers viewing the core banking engine and kind of the bank IT as some infrastructure that supports the work they're doing, whereas really what they should be thinking is that the banking stack is the bank and that those bankers are actually maintaining and supporting it. That's an interesting and very forward-thinking way of thinking about things. You guys must have spent an enormous amount of time thinking about what banking will look like in the future to help you kind of inform some of your technical decisions. How do you expect banking to change in the coming years?
I think there'll be radical changes in the technology in the banks. I don't believe that banks will disappear. And there are people who kind of go, will banks be completely disintermediated by PSD2 and things like that? I don't believe it, and I'll tell you why. In essence, when you go to the fundamentals of what the bank is there for, it is a borrowing and lending mechanism. So it borrows money, it holds equity, it borrows money, it lends money, and what it tries to do is do those things very, very well. And a good bank does those things well. And it is a fundamental part of our financial economy to do that. I mean, you just cannot run, you can't run a successful modern market-led economy without those mechanisms in place. How are people going to get mortgages? How are banks going to invest? Where are people going to put their savings? So, that need isn't going to go away. I think what is different though is that a bank, and really a bank in essence can largely be automated. Credit risk decisions, market risk decisions, things like this are very amenable to automation if you do it well. It's much easier to do those things automatically if you build the bank with that intent. It is difficult to automate banks that have been built for different purposes. Many banks today really, really struggle. They want to automate more because the cost base is so high, but it's a struggle because what they end up doing is just making the technology more complicated. So, our approach is to have a radically simple architecture that can handle all these things relatively simply, and that means that automation is far easier. Where I think banking is going to go, I think I'm not unique in this. I don't have a particularly unique insight. I just think that if we extrapolate the current trends, that'll be pretty good. So, what are we seeing? We're seeing that user experience is a prime target for how banks want to improve, and the mobile and digital-only offerings are getting much better. What we need to do, though, is get it away from somewhat superficial things about looking at your transactions or looking at your spending habits. All that's important, but make sure that you can do everything that way as well. So if you think about a complex one, applying for a mortgage, we need to be able to apply for mortgages completely digitally and without taking weeks and weeks for those things to happen. So there's definitely that. I think that banks have made every kind of normal cost-cutting measure that they can, and really, if they want to have a genuinely efficient bank, that they will need to replace their core systems. Some of the core systems have been there for decades. Some banks are just about surviving with them, but I think in the next 10 years, that is the maximum amount of time that banks are going to have with this. It is just crazy to be spending. A tier one bank would spend billions just maintaining its existing technology stack, which is money that is purely wasted. If you wanted to reinvest that IT budget, it could be spent on giving better products, having better risk management in the bank, many things. So it is a huge cost and a huge drain. So I do expect that sooner or later, most banks will change the technology from top to bottom. Nearly all bank is in some sort of transformational process, but I think more and more banks are realizing that we cannot go on adding more layers and more bits of complexity into the bank. It's time to do something. It's time to do something a bit more radical.
And how do you think banks will go about that? Will they rip out existing systems and migrate whole hog to a new platform like Thought Machine? Will it be a product at a time? Will it be a geography at a time? How do you expect that transition to happen?
Yes, no one's going to expect a tier one bank just to stop and start again. You start one day, start again the next day. But there's several paths to it. One path that many banks are doing is to launch a new bank within a bank. So it will have a mobile-only bank, and that is partly in response to some of the challenger banks that are coming along. Can they produce a fairly transactional but mobile-only experience? So we're involved in multiple banks doing projects like that. While that's good, it isn't. That helps the new customers, but it isn't going to fix the problem. You might have 10 million customers on the existing platform. So other plays that we're looking at are, can we change part of the bank? Can we take one aspect of the bank, so mortgages, or can we just take current accounts and have a look, or credit cards, for example, and have a look? Can we get that, fix that bit of the bank, get that live, show that there's proof points and trust within that, and then from that roll out to other bits of the bank. And as you said, many banks are in multiple jurisdictions. So with our product, we can build up multiple banks. It's all multi-currency. It's all multilingual. So you can build up, banks in multiple countries, and then you can actually join them together. So there are ways to get there. I think the way that we see it is that to build a new bank from scratch and onboard customers organically is one thing, but the real prize is, can we migrate banks off their legacy platform? And that means getting the customers off the legacy platform without any disruption. So we are doing that, and it's certainly very challenging, but it is the most rewarding part of it, because then after doing that, the customers have a seamless experience, and of course after they're done, they can have an improved experience, but then that allows the banks to go, right, finally we can turn this old stuff off and be free of all the problems that it brings.
I think we can largely probably agree that systems of any sort kind of have natural limits in terms of what they can deliver themselves, and where it makes sense to start to hand off some experiences to third parties. I think specifically, to your point about changing customer expectations, and a lot of, it seems, what's driving changing customer expectations is the free flow and availability of data across platforms and the new opportunities there. Presumably, Thought Machine has some dotted line boundaries around what it's looking to deliver, and will find ways to support third-party applications as we move toward a world of open banking. What's the thinking there?
Yes, so we're ambitious, but we don't want to own the whole world of banking. Well, first of all, our platform has open APIs, so it is designed that people can build their own apps on the platform. And we have apps, and we've got a mobile app and a web app that show all the functionality, but that is just our view of how it should be done. We expect many banks to build their own apps so that they have the customer experience they want. Part of the whole point of this is that banks should be able to focus more on customer experience, not have to focus on the back office stuff. So we do that. Being a kind of API native sort of company. I mean, obviously, we provide, we're all in favor of providing our information into the open banking world. We're also a good consumer of information. One of the parts of the bank we're very keen to be able to aggregate all the data from other banks. So we can do that. If you're, something you're working on now is if you're applying for a mortgage, you need to do various affordability things. You may be applying for a mortgage in one bank where your current account's in a different bank. So it'd be good to be able to pull all your transactions from your current account bank and prove your affordability criteria. So we're doing that. And we're partnering with other fintech companies. So just to pick one example, so Omfido are making amazing progress in the KYC space. And they do that much better than we could ever do, and therefore we're very happy to partner in those spaces. When companies, operate in the modern world with APIs and software as a service, it's easy to partner. When they are of the previous generation, the older generation of mainframes and legacy IT, it's more difficult. But the whole point of it is that we want to provide the best overall experience to the banking client and to their customers. And so it's whatever combination of technologies produces that is the best thing. Yeah.
Paul, what's the best way for people to find out more about Thought Machine and connect with you directly?
We're very accessible to anyone who wants to come talk to us. Get in touch. One thing I'll say is we're a very demo-friendly company. We're always demoing our products, so we're happy to give demos, give people the real feel for the technology. Happy to show everything you can do, and part of it is a kind of educational exercise in what can happen in the new cloud computing world.
Great, Paul Taylor. Thank you very much for joining us today.
Thank you very much.
Thanks for tuning into Rebank. If you like today's show, reach out. Follow us on Twitter at Rebank Podcast and join the conversation. For more on banking, fintech, and the future, check out our regular content at www.bankingthefuture.com.